There is so much about the Earth that we undervalue in our daily lives. Though human civilization has spread to every region of the world, our existence still depends on the alignment of natural phenomena that are beyond our control. Earth's precise distance from the Sun, which creates ideal temperatures for life, is a perfect example. Even the grandeur of our planet's landscapes is the product of natural events. It was plate tectonics, after all, that forced the Himalayan mountains to rise, created spectacular volcanoes like Mount Fuji and Mount Vesuvius, and shaped Earth's oceans and continents. Our planet's many peculiarities make it both beautiful and habitable, but what would happen if something changed? What if a single, elemental part of our planet was altered, and what would the consequences be for humanity and for all life? What if, for example, Earth's magnetic field disappeared? Let's conduct a thought experiment and imagine the Earth exactly as it is, but with no trace of geomagnetism. As it turns out, this seemingly simple change would have drastic consequences for humanity and all life on Earth. Some of the resulting effects would be plain weird, others would be utterly catastrophic. Of course, there is a slight chance that this would ever actually happen, but that's what makes for a good thought experiment. Let's take a look. Compasses are really nothing more than tiny magnets, and like all magnets, they align themselves with nearby magnetic fields. Conveniently, Earth's magnetic field is strong enough to force compasses to align north to south, but with our planet's magnetic field gone, compasses would point to any nearby source of magnetism. Even an outcrop of magnetic rock could do the trick. In fact, scientists have documented this effect before. Magnetic anomalies, places on Earth where nearby natural magnetism cause compasses to malfunction, are found around the world. In the Central African Republic, for example, unexplained magnetic variations in Earth's crust cause compass needles to point in random directions, rendering them useless for navigation. If our planet's magnetic field disappeared, wandering compasses could become the norm worldwide. Humans aren't the only animals that exploit Earth's magnetic field for navigation. Many birds, sea turtles, lobsters, honeybees, salmon, and even fruit flies have biological compasses, termed magnetoreceptors, built into their bodies. Birds use this ability to seek warmer climates during winter months, while sea turtles navigate the open ocean and seek beaches to lay their eggs. Scientists even think that most female sea turtles return to the same beaches every year, a feat made possible in part by their natural compasses. If Earth's magnetic field disappeared, many animals that depend on compass navigation could be in serious trouble. Sea turtles could literally get lost at sea. Migratory birds might fly in the wrong direction, threatening their survival. Honeybees might get lost trying to find their hives, which could impact the pollination of flowers and other plants. With their navigational abilities severely compromised, these and many other organisms could face extinction. Along with our biodiversity, the loss of Earth's magnetic field could alter Earth's auroras, known commonly as the northern and southern lights. These beautiful phenomena are created when our planet's magnetic field channels charged particles from the Sun, known as the solar wind, into our planet's upper atmosphere. The solar wind is usually deflected by our magnetosphere, the invisible shell created by Earth's magnetic field, but around the north and south poles, the magnetosphere dips inward like a funnel, allowing the solar wind to interact with our upper atmosphere. The result of this interaction is the spectacular, multicolored bands of glowing plasma known as auroras. Auroras on Earth have been known to shine so brightly, a person could literally read them. But without Earth's magnetic field, our entire upper atmosphere would be exposed to the solar wind, completely changing how our auroras might appear. They could even resemble auroras found on Venus and Mars. Since these two planets have no significant magnetic fields, they sometimes have faint, less colorful auroras scattered across their night sides. Thus, along with altering our polar skies, the disappearance of our magnetic field could forever dampen one of Earth's most breathtaking natural wonders. Our magnetic field doesn't just give us beautiful auroras, it keeps us alive. Cosmic rays and the solar wind are harmful to life on Earth, and without the protection of our magnetosphere, our planet would be constantly bombarded by a stream of deadly particles. The effects of cosmic rays on the body can be pretty terrifying. While on lunar missions, for example, astronauts often reported seeing flashes of light when they closed their eyes, the direct result of cosmic rays passing through their retinas. A few even developed cataracts years later. Radiation and cosmic rays are a real concern for NASA, especially when it comes to long-term spaceflight. Astronauts on a mission to Mars could undergo up to 1,000 times the exposure to radiation and cosmic rays that they would get on Earth. If Earth's magnetic field disappeared, the entire human race, and all of life, in fact, would be in serious danger. Cosmic rays would bombard our bodies and could even damage our DNA, increasing worldwide risk of cancer and other illnesses. The flashes of light visible when we close our eyes would be the least of our problems. Human health is one issue, but without a geomagnetic field, our technology would also be at risk. Satellites can and do suffer damage from solar storms, and without Earth's magnetic field, every electronic device could be exposed to high-energy particles from cosmic rays and the solar wind. In fact, solar activity has caused such problems before. In 1989, a massive solar flare, an eruption of superheated plasma from the surface of the Sun, slammed into Earth's magnetosphere, and knocked out electricity in Quebec, Canada. The power grid for the entire province went offline for 12 hours, and other nearby regions scrambled to keep their grids working. Some satellites suffered damage, as their delicate electronics simply weren't designed to handle a huge solar storm, and many tumbled out of control for hours after the flare struck. While the geomagnetic storm of 1989 was unusually massive, the solar wind is always hitting our magnetosphere, even during normal solar activity. If Earth lost its magnetic field, there would be no magnetosphere, and no line of defense, even from weaker solar storms. The Sun's natural wind is so powerful, it can easily rip gases out of a planet's atmosphere until there is little gas left at all. In fact, this likely happened to Mars. Mars was probably once a lot like Earth, with oceans of water and a thick atmosphere, but unlike our planet, its magnetic field disappeared billions of years ago. Its atmosphere was left totally unprotected, causing it to be ripped away into space.